DNS and bind. In this nugget, we're going to talk about the domain name system and bind, which is the standard DNS software for Linux machines. We'll start by looking at the big picture. We'll look at how name servers take a domain name like www.ibm.com and turn that into an IP address. We'll also do that manually using the dig command so that you can see the kinds of things that are discovered during that process. And then we'll move on and look at the necessary software and configuration file settings to get DNS running on your system. So pull up a chair and let's get to work. Let's start with an overview of DNS, the domain name system. The easiest way to think about DNS is that it's a phone book for the internet. It helps us translate between names and numbers. So as humans, we like to refer to things by their names, like www.cbtnuggets.com or ftp.download.com. We remember things like that very well. However, all the machinery on the internet, the routers and the switches and things like that, like to route traffic around based on their numbers, their IP addresses. So we have to have some mechanism to translate between names and numbers, and DNS is that mechanism. Now, the domain namespace is similar to the file system structure in Linux. It's a very hierarchical structure. Let me show you a picture to show you what I'm talking about here. So the very top level of the domain namespace is a dot, just like the top level of the Linux file system is a slash. Okay? And then underneath that dot are all the major domain categories, .com, .edu, .ca for Canada, .tv, and so on. Okay? Now, just like the Linux file system has /etc and /user and /var and things like that. Okay? So underneath the com domain are all the different things that have a .com domain. CNN.com, cbtnuggets.com, linux.com, and so on are all under the com domain. Underneath those particular domains are the individual machines on that domain. So like www.cnn.com, ftp.cnn.com, mail.cnn.com. Okay, so each of these nodes in this tree has what's called a resource record. I've just drawn it for this particular node, but every node in this tree has a resource record, and the resource record contains all sorts of different information, potentially. I've just listed a few of the more important ones here, and I've used their abbreviations because we're going to see these abbreviations when we start poking around through the domain namespace. So A is the address, so like the IP address of www.cnn.com would be in the resource record for this node. Okay? The name server would be the authoritative name server. What machine knows for certain that www.cnn.com has a particular IP address? The start of authority record contains information like email contacts for the domain and things like that. Pointer records are useful when we go backwards, when we try to look up from a particular number what is the name, what is the domain name for that particular IP address. That's where pointer records come in. And then there's like a mail transfer record. So what's the mail server for this particular domain, cnn.com or mailcnn.com or whatever. Okay, so that's the kinds of information that is stored at all the various nodes throughout this hierarchical structure. Now the next piece to this puzzle is the idea of name servers. Name servers hold information about the structure of the tree and also all those resource records that are contained in the tree. And every domain in that tree, every node of that tree that we were just looking at, has what's called an authoritative name server. And when I'm saying every domain has an authoritative name server, I don't mean just like www.cnn.com has an authoritative name server. You know, the root directory has an authoritative name server. The .com directory has an authoritative name server. The .com authoritative name server knows where to get more information about cnn.com and cbtnuggets.com and linux.com and so on, but it doesn't know any IP addresses for like www.cnn.com. That would be too much information to store in one place. Okay, so instead, the authoritative name server for the com domain keeps track of the, the next level domains and where to get that information. Then somewhere else on the internet is an authoritative name server for cnn.com. And that authoritative name server then contains information about www.cnn.com, ftp.cnn, mail.cnn, and so on. Okay, and the kinds of things that are in that authoritative name server might be the IP address of www.cnn.com and so on. Okay, so that's the next piece of the puzzle, is the name server. Now, the nice thing about name servers in practice is that they can cache information, they can store information, so that repeated lookups of the same domain are fast. You don't have to go out and go through and follow this whole chain of command. You can just look it up in your cache and say, okay, somebody already asked for Google like 7 minutes ago. I could just respond exactly what that IP address is. All right, so the next piece of the puzzle is the idea of resolvers. Now, resolvers are the programs that actually track down these resource records. The resolvers know how to contact what are called root name servers, and they follow that chain of the chain that they find until they find an authoritative name server. So they do exactly what we were talking about. They go to the root level and they ask the root level name servers, how do I get to www.cnn.com? Well, the root level name server will say, well, I know how to get to .com. Here's some servers you can ask. Then you ask one of those servers, and then from there, that'll tell you, well, I know how to get to CNN.com. I know an authoritative name server for CNN.com. Then the resolver would go there and resolve the chain eventually. Okay? There are 13 root name servers out there on the internet, and they all have this structure: a.rootservers.net, b.rootservers.net, up to m.rootservers.net, I think is the 13th one. And they're distributed all over the world. There's a whole bunch in the U.S. They're in Virginia, Maryland, California. There's some in London and Tokyo, and I don't know where else they are. But you can look up root name servers on the internet, and it will show you where they all are in the world. And that is the first thing that the resolver does when it's trying to determine an IP address for a particular domain. It will go to the root name server first. Now what I want to do is use the dig utility to act like we're a resolver program. I just want to take you through the steps of what name resolution has to go through and how things are distributed to really explain that whole picture of that hierarchical structure and all the different resource records that we'll find along the way. So what I'm going to do here is I'm going to use the dig utility, and I'm going to probe one of the root level name servers. I'm just going to pick k.rootservers.net. And I think k.rootservers.net is in London, England. And then what I'm going to do is I'm going to probe that particular root name server out there for the IP address of www.wwu.edu, which is Western Washington University's homepage in my hometown of Bellingham, Washington. So I'm going all the way to London to find the IP address of a university that's 2 miles away. Okay, so I have to specify what information it is that I want from that root level name server, and I'm going to use the A abbreviation to represent the IP address. Like we were just talking about all those different abbreviations, A stands for the address of this particular domain. All right, I'm also going to specify an option to the dig command for no recursion. So if I didn't specify no recursion, what dig would do is it would go out to this root level name server. The root level name server would say, okay, I have information about edu domains, and here's the information that I have. And then dig would just follow up on that information and follow it and follow it. And then we would never see, sort of all the intermediate steps, which is all the interesting stuff. Okay, it would just spit out the IP address at the end. All right, so instead I'm going to specify no recursion so that we have to do multiple dig commands to get the actual information. All right, so let me hit enter here, and now you can see that a bunch of stuff got printed out to the screen. Okay, this is the results from the dig command. So I did one query. I didn't get an answer, though. Notice it didn't get an answer. It gave me 8 authorities and 8 additional pieces of information, it says. It does say status no error, though. Okay, so let's go down here to the question section. It says www.wwu.edu, and it's looking for the address. All right. In the authority sections, notice what comes up. A bunch of domain names come up, name servers here for the edu domain. All right. So these name servers contain all the information out there about all the different edu domains that exist. Okay, and those are the names of those servers. It's like A3, the B3 is not in there, but C3, D3, E3, and so on. Okay, all these different name servers at nstld.com. All right. In the additional section, dig tells us not only what the names are, but the IP addresses of those name servers. Okay, and tells us how long it took and so on. All right, so now what I want to do is I want to go back and probe one of these particular name servers for the exact same information. And this is what a resolver would do. A resolver would take this piece of information and say, okay, you have all this information about edu domains. I'm going to pick one of these at random and then follow it along. Actually, it doesn't pick it at random necessarily. What it does is if it got bad performance from using one of them, say it used H3 and it took like 6 seconds to resolve the information from H3, then internally the resolver would say, okay, H3 is at the bottom of my list. I'm going to try C3 first or whatever. And whatever performance, whatever server provides the best performance is the one that it will continually use after that. And the reason for the change in performance is, you know, maybe the servers are loaded, but also just the physical location of these servers. If one of these servers is, you know, in your state or in, you know, your half of the country, it's going to be faster than if it's halfway around the world in Tokyo or London or something like that. Okay, so what we're going to do here is we're going to now say dig, and I'll say at, and I'll just pick one, I'll just pick G3. Okay, G3.ns TLD, TLD.com. Okay, I'm going to give the same information, www.wu.edu, still looking for the IP address, and I'm still going to specify no recursion so that we have to do this all again. Okay, so let me hit enter here. Again, we get a whole bunch of information from the dig command. Notice again it says query 1, answer no. And then it gives some information. Here's the authority section now, is giving me authoritative name servers for the www.edu domain. And there's 3 authoritative name servers there, and there's 2 addresses that come out. Okay, and those 2 addresses are the addresses of 2 of these authoritative name servers that came up in the authority section. Okay, so now what I'm going to do is I'm going to use dig once more. I'm going to pick one of those authoritative name servers, viking.wwu.edu. I'm going to specify www.wwu.edu, specify the address, specify no recursion, and do it again. And now what comes out is an actual address. Now the other thing that's in the answer section, notice up here, it says query 1, answer 2. All right, so in the answer section, there's 2 things that came up. First is this www.wwu.edu, and there's a C name of raccww.edu. Okay, this is kind of like an internal name for this outside name. Okay, and then the internal name has a particular address. So this is something they set up internally to their network so that it would route to this particular address. But there it is. There's the IP address that would be used if I typed in www.wwu.edu into a web browser. Another thing that a mail server has to be able to do is it has to be able to do what are called reverse DNS lookups. In a reverse DNS lookup, you start with an IP address and you're looking for the domain of that IP address. Sometimes you might do this to verify the integrity of some message. Say you get some mail message, and you know, in mail messages certain things can be forged by people. Okay, so you know it came from a certain IP address, and they claim it came from some certain domain name, and what you can do is a reverse lookup on that IP address to see if it matches the domain name, and if it doesn't, then you can assume that it's a bogus message or spam or something like that. So the way that you would do a reverse lookup with dig is you would still start by specifying the root servers, okay, the particular root server that you want to use, and then you would specify the IP address. But you can't specify the IP address just sort of straight up here. And the reason is, think about the hierarchical structure of that tree that I was showing you. You know, we think about domain names as like www.cvtnuggets.com, but in that hierarchical structure, it's com, then it's CBT Nuggets, then it's www. That's the order that we discovered it by using dig in the forward DNS lookup, okay, when we were doing a lookup of IP address for a particular domain name. And the same thing is true of IP addresses. What we have to do is we have to flip that IP address around and put the last octet first and the third octet second and so on to look it up. So if I'm going to look up 128.242.116.216, the way that I would do it is I would look up 216.116.242.128, and I also have to append inaddress.arpa on the end of that. And that's a special domain that's out there that allows us to do reverse DNS lookups. The resource record that I'm going to look for is the pointer record. Remember, the pointer record is the record that, given an IP address, that points back to the name. So it's kind of the reverse of what we were looking at before. And then I'm also going to specify no recursion here. So I do that, and now you can see the way that this worked, right? I'm searching for this particular address, and before, when I searched for a domain name, what was in the authority section were things like com dot. So it was resolving the com part of a particular domain name lookup. Here, what it's doing is it's resolving the 128 part of the IP address, and that's why we had to put that last, because that's the first thing that has to get resolved. Okay, so we didn't want to mess with that ordering there. All right, so what I'm going to do now is I'm going to take the next step, and I'm going to say dig at one of those name servers that's given to me in the authority section, and I'm still going to search for the exact same IP address, 216.116.242.128.inaddress.arpa, and I'm still looking for the pointer record, and I'm still going to specify no recursion. And now you can see it's resolved 242.128. We're going to do another one here. We're going to search for ns3.vario.net, and I'm still looking for the same exact IP address here. Okay, and I'm going to hit enter there, and now you can see we're getting down even farther, and now I'll do one more here, one more dig command. I'm going to say dig at c.ns.vario.net for 216.116.242.128.inaddress.arpa pointer plus no recursion. Okay, and now we come out, and finally we got an answer. That address is now points to mail.cbtnuggets.com. So that's the kind of thing that you would check, especially in mail messages, is one particular example of times when you would do a reverse DNS lookup. And if somebody was claiming to have sent a message from mail.cbtnuggets.com, we did the address, we saw that it resolved to mail.cbtnuggets.com, then they're not trying to pull a fast one on us, and we would let the mail go through. Okay, well now let's take a look at some of the software that you need to have installed on your system, and we'll also look at some of the configuration files and the settings you need to make in there to get DNS up and running on your system. So first you have to make sure you have the correct software. The name of the software package is called Bind. Bind stands for the Berkeley Internet Name Domain, and the latest version of Bind is Bind version 9, and you should definitely be running Bind version 9. Okay, so Bind comes with a name server daemon called named. It comes with resolver libraries and some other utilities as well. So now that I know that I have this all installed on my system, we can just go and take a look at the main configuration file for the name server daemon, and that's called named.conf. Okay, and that's in the etc directory. So let's take a look at this file. Now on SUSE Linux, they give you a sample configuration file for named.conf that works as a caching-only name server without modification. What's a caching-only name server? Remember before I was telling you that name servers have the capability of caching some of the data that they request. So when you go out and you request, google.com or something, that's translated to an IP address, and you go off to that IP address and pull up the web page. Well, a caching-only name server, if you were running a caching-only name server locally on your system, then you wouldn't have to make those requests out to the, the ISP's name server repeatedly, because you could store some of that data locally, some of those translations from domain name to IP address can be stored locally on your system. So that'll save you some time if you're requesting the same domains over and over again on a web browser, for instance. All right, so this makes sense for people that are connected to the internet with like a DSL connection. See, which is me, you know, that's my situation here. So I don't have my own domain. I don't need to have an authoritative name server for my domain that will answer queries about all the various computers that are in my domain. Right? My ISP takes care of all that stuff. My ISP provides me with a name server, and I just use that all the time. But I can set up a caching-only name server on my machine to save some of that internet traffic that goes out to the ISP's name server to do some translation. So the caching-only name server can do that for me. If you do have your own domain, then the settings in this configuration file are not going to be sufficient for you. In that case, SUSE Linux gives you a sample config file in the user shared doc packages bind directory. And you can also find sample config files if you have your own domain out on the internet. Do a search for DNS how-to, and you'll get a whole tutorial of how to set up a caching-only name server, how to set up a DNS server if you do have your own domain, and so on. Well, the first thing that actually gets set in this named.conf configuration file is a directory, and this defines the name daemon's working directory. So on SUSE Linux, it's var lib named, and then all of the other things in this directory are sort of relative to that, unless they start with a slash themselves. Okay, so if we go down here, pretty much almost everything's commented out. I just want to go down to the important part here, which is the zone definitions. So the zone definitions, there's 3 of them for 3 different uses. One of the zone definitions is for a dot, which means that's for the root level name servers. Okay, the type of that zone definition is a hint, and the file is root.hint. Now root.hint lives in that var lib named directory, and this contains all of the root level name servers and how to get to those root level name servers. So if you need to resolve something at the root level, then that's where you're going to go. Okay. Then the other things that are defined in here are, one of them is a local host definition. Here, that's a master name server. So you can have, for a large domain, you're going to have a master name server. You're also going to have some slave name servers as well. The file that defines this zone is called localhost.zone. That's also in that var lib named directory. And the last zone has to do with reverse DNS lookup. So you can see here that it's like the 127.0.0, which talks about the local host, but it's got that inaddress.arpa appended to the end, and that's what we use to do reverse DNS lookups. Okay, so what I want to do now is that we've seen this in the named.conf file. I want to go and look at each of those files in the var lib named directory so that we can see how they're configured. If we do an ls in the var lib named directory, you'll see the 3 files that were referred to back in the etc named.conf file. Let's take a look at the root.hint file first. Remember, this is the file that contains all the information about the root level name servers. And you can see down here, each of the root level name servers is mentioned, and then there's an IP address for that name server. And as we go down, you'll see it goes from A, B, all the way down to N. Okay? Now, the thing about this file is that it has to be kept up to date, or you won't be able to find the root level name servers out on the internet. Now, the root level name servers don't change like every other day or anything, but if they did change, it would be catastrophic to DNS running on your system because you wouldn't be able to find any of the root level name servers. So for that reason, this file is made available by Internic. You can get it at this file name at either one of these servers, and then you can always make sure that this file is up to date. Okay, so that's one of the maintenance issues with DNS, is making sure your root.hint file is up to date. Now let's look at some of those other files that are referenced by the named.conf file. We'll start by looking at localhost.zone. The very first thing that's set in this file is a time to live, and it's set to be equal to 1 week. So what this means is that if some name resolution is done for you, you can cache the result of that name resolution for 1 week before you ask your name server again for that data. Okay? Some of the other settings in here really have to do with if you have a domain set up with a master name server and what are called slave name servers. These settings have to do with how often the slave should look at the master to get updated information. So the slave should refresh from the master every 2 days. If the slave is not able to reach the master, then it should try again in 4 hours. The expiry time, like if the slave tries to reach the master and the master is down or not functioning, then it should wait up to 6 weeks before it just scraps all the information that it ever learned from the master. Otherwise, for 6 weeks, it can continue to use whatever information the master had given it before. Okay, so this is the kind of stuff that can be set, like I said, if you have multiple name servers on your domain. So that's what a zone file looks like for localhost. If we look at the zone file for the reverse lookups, the 127.00 zone, same kind of thing is set. Okay, there's a time to live of 1 week, and then all the same settings are done for slave name servers. These serial numbers, it's set to 42, and they reference Douglas Adams here. If you've never read Hitchhiker's Guide to the Galaxy, you're just scratching your head. But that's just the default serial number that gets set in here. Anytime you make a change to these, you should increase the serial number. A more standard notation for the serial number is like a 4-digit year followed by a 2-digit month followed by a 2-digit day followed by a revision on that day or something. The serial number can be very, very long, and so it's nice to have an explanation of when the last time it was updated in there, and that's a more common setting for the serial number than 42, but it is a good inside joke. And the last thing I wanted to do was just point you to the DNS how-to file. The DNS how-to file has all sorts of stuff, everything from what we've talked about, which is setting up a resolving caching-only name server, and then it goes into setting up a simple domain, and then it goes into setting up a real domain. It also talks about some maintenance and security issues. It also has a section on migrating to Bind 9. So if you were running a DNS server on an old version of Bind, then these are the steps that you have to take to get it to run on Bind 9. Under the maintenance section, it's got a script that you can use to go out and update your root.hints file. And that's pretty much all that is required for maintenance of DNS. Once you have everything up and running, that's the only thing you need to update regularly if you don't change anything in your network. All right, well, it's time to wrap up our nugget on DNS and Bind. We started by giving an overview of the domain name system, and we talked about how the domain namespace is kind of similar in structure to the way that we view file systems in Linux. It's this very hierarchical structure. And then we talked about how domain names are resolved to IP addresses. And then we went through and actually did some resolution on our own using the dig utility. And we went through and saw all about the root level name servers and how they sort of pass command down to other name servers depending on what kind of address you're resolving. We also talked about doing reverse lookups with dig as well. And then we started talking about the Bind software, which is the de facto standard software to implement DNS on Linux machines. And the main configuration file for that was the named.conf configuration file. And this is where you set up the directory for Bind to use, and you also set up zone files, which in turn set things like the time to live. And the example that we did was for a caching-only name server, since I'm on a DSL connection. But if you're in a situation where you have your own domain, then you should refer to the files that I mentioned and the documentation on the how-to page to set up Bind and DNS to run on that sort of situation. Well, I hope you found this nugget informative, and thanks for watching.